Tencor dual wavelength FLX 2320 stress measurement system. This system is interfaced to a computer, and the system boots up into a DOS-based program. The operating system is DOS 5.0, and the FLX system is very simple here. And this is the surface where the sample is usually placed. I have this is a 100mm centering tool, and this is a heated chuck. When it's the variation of stress of a wafer on a wafer is to be measured with respect to temperature. The system can be programmed from a recipe on the PC, and the stress will be measured depending on the set number of data points requested in the recipe, and the data will be plotted. So I'm going to so often a silicon wafer like this, ideally a new wafer is always flat, but in the process of either a deposition or when certain layers are etched out, there is a tendency of the wafer warping or curving, or in other words, there will be a change in the flatness, and which could be measured using this system by profiling using a laser beam across the wafer. So the laser, either a 670 nanometer laser or a 750 nanometer laser, can be selected, and the laser light will be bouncing off the surface and onto a detector, and it will plot the surface quality or the profile of the surface. This is a non-contact measurement device, and care should be taken to make sure that the samples are not touched with bare hands. So as soon as the PC is boots up, it boots up into this screen. This is a FLX stress measurement version 3.02 software, and various items, menu items are here. I mean, the main menu, there is a stress measurement. You select it with enter, and we can, in the stress measurement, we can, with no film, a wafer can be scanned, and that will be the no film measurement. And a single stress is you can measure, you can scan it once, and here you select a data file, and you add a ID to the sample, and then any notes or comment requested, and then the film thickness. So often a stress is measured after a film is coated, so first you measure with no film, and then you measure with a film on it. And then the third thing is the stress versus time. So whenever there is a film which could change its parameter, the stress values change over time, that can be measured here, and here you enter again the data file, the ID of the wafer, and then film thickness, and total time in hours and minutes and in intervals. So you can have several scans and the data could be plotted. And the stress temperature. So in this screen, the measurement takes place. Again, here you have to first select a data file. So to select a file, if you click on F1, it will come up with the list of data files available will be listed. Any user can go, can record as many data points in one data file as they wish to. These are all the previous users' data files, and once you select a data file, then you go to the ID, and here I will say test lead 1, and then go to the comment, just scan temp, and then the film thickness. So this is very important. You have to enter the right film thickness. So in this case I enter about 128 angstroms, and then you say create recipe. If you press if you say yes, then and enter. Now this is the recipe where we enter the parameters, such as you click enter again, you enter the temperature. So you want to go up to 100 degrees Celsius, and in about, say, 25 minutes, and then number of readings, you want to say about 10 readings, and the system will calculate the ramp rate of the temperature profile, degrees centigrade per minute. And then the next step, you press enter again, go to the highest temperature that can be set on this is about 505 degrees, and by changing in the configuration file we can always limit the highest temperature it can go to, and then so this is just a test pro recipe I'm writing here. So again, during the so once we do this, we can always by pressing F2, we can go to to initialize the program. So I'm going to quickly switch back to the main menu and show the other screen utilities here. The utilities enables to check the intensity of the laser. Number 2 is the calibration procedure and move the laser beam. So the laser beam is moved using a linear drive made by Aerotech Incorporation, and when we select move laser, we can either jog it by using these left and right arrow buttons, or we can set it at the center, or we can move it a desired distance from the center, either negative value or positive value in millimeters of distance. Now only care should be taken that you move that do not hit the end or the limit of the scanner. Now the scanner is capable of profiling up to 8 inches or 200 millimeter wafers. Now I'm going to show how. So to come out of a menu, you always press escape key. Now I'm going to show how to check the intensities. First, you have to load a sample. I'm just placing a sample on the sample holder, and then now only when there is a sample, a reflective surface, as a silicon wafer or a standard or a mirror, then only you will see the intensity. So you click F9, then you can measure the other wavelength, that is 670 nanometers. F9 takes you to 750 nanometers. So various intensity levels, or it will also measure both of the lasers at the same time and give you a reading. So also next, we have a editor menu here. We can edit files, and there is a data analysis menu where after a scan is complete, various data can be retrieved and then it can be analyzed, or the records can be compared, or we can do various analysis on this system. And this is a process program. Every time a scan is to be made, first a process recipe, appropriate process should be selected. In this process program, we select maximum scan points, and then a storage directory on the or the data file, or where the directory where the data file is stored. And then the low intensity alarm is, say the sample has some pattern on it, then at times there may be the laser intensity will be very low. At that point of time, the system will alarm and stop scanning. So always it should be specified what is the expected low intensity alarm. And then these are the other parameters, or the elastic modulus and substrate thickness and wafer diameter should be entered correctly. And the elastic modulus is dependent on the material of the sample, and then you won't always select wafer diameter either slightly smaller than the wafer diameter in millimeters, or else during a scan, if the laser bounces off the surface where there is no wafer section, then it will again run into an error message. So the whole diameter is in millimeter. This is for compact discs, and if it is a wafer, the whole diameter is 0. And then the units can be selected in million Pascal, and then various other units can be selected depending on the desired measurement range and range. Now the wafers flat can be selected, either a flat or a notch type, and then after editing this we have to say save changes, or just exit by typing letter N. And then here is the configuration of this system. This tells what is the configuration of this machine, and it has various standard values which are specific to this machine, such as the table axis indicator, wafer detector distance, and then the stepper drive that drives the laser head and its number of steps. And then there is a axis to wafer center distance, again in inches, and then the impingement angle and the overtemp protection. So these configuration parameters cannot be changed, and the serial number of this unit is 4198, and the serial number is to be used to compute the password at the time of calibration. I will get back to that in a minute. Now there is a diagnostic screen, and in this diagnostic screen it indicates whether the temperature controller is working or not. And the temperature controller, which is the Eurotherm 847, is connected to the serial COM port 1 on the PC, and it is indicating that it is connected. And then you press enter. There is a parallel port currently is disconnected, and these other settings are indicated. You have to press enter in order to see the condition of the lasers. In the diagnostics, it will indicate simultaneously the intensity and the position of the laser, and it shows whether it is okay or not. Due to some reasons, if the laser is not properly aligned, then it will not show okay. So before proceeding to take the first measurement, I want to show the facilities on this system. Okay, the system is interfaced through two driver boards, an analog board and a motor driver board, and these PCBs are connected through these ribbon cables. And there is a RS-232 connector here, 25 pin here, and a 9 pin here, which is connected to the serial port 1, and the keyboard. And this system is a very basic system, and it has cooling inlets and cooling outlets, and inert gas inlet and inert gas outlet. So the inert gas is to keep the sample area out of moisture and any reactive gases. And then you have a cooling inlet here. It can go up to 500 cubic feet per hour flow, up to 40 psi. You can use either dry nitrogen or any argon, depending on the facilities available, and the details are listed in the user. Certain accessories. This is a Clampdown cover that goes on top of the sample holder like this, and you have to secure it with these thumb screws. This makes sure that the wafer during the scan is not either lifted up or it is not shifting, so it secures it on the sample. I'm going to run a first scan on this wafer just to show how this system measurement is to be taken. So I have already selected a file here, just in case. Yes, that's the file, and then ID. It's a test. I'll just say 556, and then comment just wafer blank, and then now substrate thickness is about 580 micrometers. And then change the process program. I'm going to change the program to select if I say yes and enter. So I have a program written here, 100 LW for the 670 nanometer process program, and I'm just entering it. So this system should be installed on a level table, and the unit requires to be leveled properly, and if possible, if the computer can be placed on a. So here is a first measurement taken, and it is showing a plot that this particular wafer is a little warped. About radius of curvature is about 105.797 meters. So I'm going to just change the sample. Let me select a flat, which is supposed to be the radius of curvature should be very high, and so I'm going to say enter, and it goes back, and so in this screen it only shows the value of the plot, and I'm going to press just to run it again, just leaving everything same. Let's say the substrate thickness here is different because I have a sample which is a standard 12300, and then now it will start measuring, and at the end it will give again a plot. So this time it shows the radius of curvature as 5.773 exponential times 03 meters, which is 5,777 meters. It is very flat, and the bow is about minus 0.22 micrometers. Now I'm going to change it to a non-curved surface, which is 100 millimeters standard, and the thickness is to be given as 12,827 microns. So I'll say enter, and then so that will be the detailed procedure is included in the manual, and then you press F2 to start measuring. So this is a approximately 20 meter standard, and the scan duration, we have selected 50 points, and it is pretty quick. It is less than 15 seconds. So the radius of curvature is 19.718 meters. Now I'm going to measure do the same measurement with the second diode. So in order to do that, all I have to do is change the program, and that will be the 100IR.PRC. So that's the program I'm going to select. Once I selected it, the laser mode is changed and it started to measure. So this one measures about 20.159, which is within the 2.5% variation of the tolerance limit with respect to each laser, and a slight alignment and adjustment and fine-tuning can be performed by a trained technician or engineer on this system. And the upgrading of this PC involves using proper application software, and also it does call for upgrading the hardware as well. Only either a manufacturer representative or who are trained personnel should attempt to do the upgradation at this point. This system will not include any printer or any standards. If standards are designed, you have to contact the sales department. So I'm going to show a way for how to do a temperature recipe. Let's do a single stress measurement, and again you have to select a file of film thickness. So I selected a file, and then I say stress 1, comment, test, and then film thickness. I will just say about 2000 angstroms. So I'm using a second wafer here. Let me see how it measures. Okay. When we try to do the stress measurement, there should be first a scan with an ID with no film scan. Only then the stress can be measured. So in order to do that, I will do a first no film scan, which I'm going to do it on a blank wafer. This is just to simulate that the stress measurement option is working. So I'm going to select the ID, stress 1, and comment, test, fourth, APR. And then substrate thickness is correct, not correct, 580 microns. I'm going to leave, I'm going to change the stress program to say low wavelength just for, so now it is measuring the sample with ID stress 1. I'm going to use this data and take a single stress measurement. So this is the radius of curvature of measurement. Now I'm going to do the stress measurement using a single scan. So say enter stress 1 common say coded, and then so now it's going to do the stress measurement just to show that you're able to measure using the correct sample ID. This is only a demonstration. These values have no meaning at all. So the stress is negative. It indicates that the radius of curvature has changed due to whatever reasons, and that these measurements should be relative comparison measurements. That is, you measure a blank paper and then you scan it on a coated paper. So I'm going to do a temperature. So stress time is the same, but it will measure the values with respect to time and stress temperature. So I'm going to use the same ID of the sample, and then common temp response, and then film thickness, and then create a recipe. You have to say yes, and then let's see, we'll go up to say 150 degrees in about 30, 15 readings, about take 5 readings. So that will be, readings will be taken every 5 minutes. So the next step is so we go to 50 degrees in about 50 degrees in about 30 minutes. Readings again 5, and then so once the recipe is entered, all you have to do is press F2, save changes, yes, and then filer, the user file is the same, and so we have to type storage file name, and then press enter, or press F1 for file list. You press F1, and then you have to select so each recipe can be stored using a .rcp file here. So I'm going to select temp test. So the temp test file is the name of the file for this particular recipe. And now the furnace stabilization delay, and in order for the temperature to start, we have to turn on the heater and fan switches. Only then we will see some action going on in the temperature control. So this is a 15 minutes process where the temperature will ramp up. So I will record this in steps of every 5 minutes. A useful reference manual and a service manual will be included with this system that will explain what should be the parameters on this Eurotone controller and how to align the laser. So each laser is to be aligned separately. Right now there's a scan going on, and the temperature versus the stress data is being recorded. So it completed a scan, and now it took the first measurement. So after again a few minutes, a new value will be recorded. This is the temperature with respect to temperature changes. So take one more point, and we'll take at the end of this timer here. We will take the recording, and I will. So this indicates that the measurement is complete, and the scanning is intermittently stopped because all the points are below intensity limits. So it's definitely something to do with this recipe parameters. So I'm going to press enter and check what is going on. So this is how a operation of this system has to be done. So it does show the intensity is very, very low. So if I change the sample, because this sample has a coating and hence the variation in the intensity levels. So So these are the factors to keep in mind while so I'm going to enter quickly a number. So the setting of the parameters is very important for this system, and appropriate selection of parameters will go through the process of scanning without any errors. temperature versus stress measurement, profile completed, and it is at now 150 degrees. Now it's always important to verify the intensity levels when a sample is changed. So coming to the other features of this system, so the calibration password for this unit is 5539, which is sum of serial number times 251 plus 17. This is to be performed in such a way, following the manual procedure. Each knob has to be adjusted when the screen prompts to adjust the micrometer. It has to be changed gradually, and before at no point of time the calibration should be disturbed unless the stage is level and the laser is aligned perfectly, and the laser intensities are also verified.